Hello, welcome to today's class. Today's class will be on intelligent agents. It will be the first class on intelligent agents. So, what actually is an agent? To answer this, let's consider this diagram. And it says that an agent is anything that can be viewed as perceiving its environment through sensors and acting upon the environment through actuators. So we have an environment, and the agent perceive the environment using sensors, and the agent can act upon the environment using some actuators. So to give you some example of agents, we humans are also agents, and a human agent have eye, ears or other organs. So using this, using eyes and ears, we sense our environment, and then using our hand, legs or vocal tract, we act upon the environment. Then it can be a robotic agent. So in case of a robotic agent, some of the sensors that it may have are, it may have a camera to perceive the environment. It may have infrared rangefinders to sense the distance from another object, and it may have some other sensors like temperature sensors or humidity sensors, and then the robotic agent can act upon the environment using some motors, by actuating some motors. Or your agent may be simply a software agent, and in case of software agent, it will receive key press, or can read a file, or it will receive network packets over the internet, and these would be the sensory inputs to the software agent, and the software agent will act upon the environment by displaying something on the screen, or writing something to the files, or sending something over the internet, some network packets over the internet. So with these examples, I hope it is clear what a agent is. And now to explain what a percept is. So percept refers to the agent perceptual inputs at any given instant. So at any given instant, what are the perceptual inputs? What the sensors are reading from the environment, and that will be the percept at that given instant. And then we have a percept sequence. And percept sequence is the complete history of everything the agent has ever perceived. So it could be an infinite list of things, the percept sequence. To make it more clear, let us consider a driverless car. So in a driverless car, the agent through its camera may see that there is a right turn 30 feet ahead. So that would be the percept at that point of instant. Now at the next time instant, the percept may be that the right turn is 15 feet ahead. So it has come closer to the right turn. So we are now 15 feet away from the right turn, and we also see some speed breaker. So at the next time instant, our percept is that we see a right turn 15 feet ahead, and we see some speed breakers. Now the percept sequence is the two percept. The first percept being that there was a right turn 30 feet ahead, that was the first percept, and the second percept is the right turn is now 15 feet ahead and we see a speed breaker. So both the percept together will make the percept sequence. And then maybe in the next time instant, we may see that the right turn is now 10 feet away and we see a pedestrian crossing the road. So that would be the new percept, and the percept sequence will be the 3 percept that we have seen so far. So I hope it is clear what a percept is and what a percept sequence is. Now the agent's behavior is described by agent function, and what the agent function do is it map any given percept sequence to what action needs to be performed. Remember, the agent acts upon the environment using some by performing some actions. So what action needs to be performed is specified by the agent function. So to go back to the example, when we said that the percept was that we see a right turn 30 feet ahead, so given that percept, maybe the behavior of the agent should be that it applies brake to slow down in case it wants to take the right turn, or maybe the only option is to go right. So if we see a right turn there, I have to apply brake. So that would be the action, applying brake. And that applying brake, the fact that we have to apply brake is specified by the agent function. So given a percept sequence, what action needs to be performed is specified by a agent function. Now the agent function may be implemented by a agent program. So maybe we have to write the program, and the program will implement this agent function. So the program that implements the agent function is the agent program. So given the percept, the agent program will tell what action needs to be performed. So whereas the agent function is an explicit external specification, the agent function is an external specification, the agent function may be implemented using a program by agent program. So agent program is something internal, whereas agent function is maybe a specification, like a table we write to specify the agent behavior. When the agent function gets implemented in a program, that it becomes agent program. Now to give you an example, let us consider a simple example of a vacuum cleaner. So we have a vacuum cleaner, and for simplicity we will assume that the environment of the vacuum cleaner consists of only 2 rooms, A and B. So for the vacuum cleaner, as far as the vacuum cleaner is concerned, only 2 rooms exist in the world. So it will operate only in these 2 rooms. And now there may be some dirt present in the rooms. Now what the vacuum cleaner will perceive is it will have sensors to tell what its current location is. So it will need a sensor to tell what its current location is, whether it is in room A or whether it is in room B. So it will perceive the location, its location, and it also needs to perceive, it also needs to find out whether the room is dirty or not. If it is dirty, it has to clean the room. So it will also perceive whether the room is dirty or not. So it will perceive 2 different things: the location, its location, and whether the room is dirty or not. And what are the actions that the vacuum cleaner can perform? It can move right. In case it is in room A, it can move right and try to go to room B. And in case it is in room B, it can try to go to room A by moving left. So one of the action is move right, the other action is move left, and in case the room is dirty, it can try to suck the dirt and clean the room. So that is the third action that the vacuum cleaner can perform. And the last action that it can perform is like do nothing. So it perceives two different things, the location and dirt, and it can perform 4 different actions. Now a simple agent function that you can think about, what should be the behavior of this vacuum cleaner? What should be the behavior of this vacuum cleaner? We can specify it using a agent function. You may come up with different agent functions, but one of the simple agent function may be if the current room is dirty, then suck to clean the room. If the room is not dirty, if the current square is not dirty, then move to the other square. So this is a simple agent function to specify what the behavior of the vacuum cleaner should be. Now we can table it, we can create a table for this agent function, and once we table it as an function, we may get a table like this, where we have the percept sequence and we have what actions needs to be performed for a given percept sequence. So what are the possible percept sequences for the given vacuum cleaner? If we think that initially the vacuum cleaner is in room A, remember the percept sequence is sequence of percept, and in our case the percept consists of two different things, the location and whether the room is dirty or not. So if we consider that the vacuum cleaner was in room A, initially it was in room A, and if we consider that room A is clean, so the first percept would be A clean. That's one possible percept. The other possibility is the vacuum cleaner was in room A, but the room A was dirty. So that is the second possibility. Another possibility is to start with, the vacuum cleaner was in room B and room B was clean. So that is the another possibility. And the other fourth possibility is to start with, the vacuum cleaner was in room B and room B was dirty. Now for given these 4 percept, what are the actions we need to perform? It's already specified in the agent function. It says if the current square is dirty, then try to clean the room. If the current square is dirty, then try to clean the room. Otherwise, you move to the other square. So in this case, if we consider the first row, we are in room A and room A is clean. So what, according to the agent function, we should try to move to the other, because it is clean, we should try to move to the other room. So we have to try to go to, because we are currently in room A, we have to try to go to room B, which means we have to move right. So the action would be move right. Now the other possibility is we are in room A, but room A is dirty, and again the agent function specifies that if the current square is dirty, then suck. So here we are in room A and the room A is dirty, so according to, as per the agent function, we should perform the action suck. Now the third row tells us that we are in room B and the room B is clean. So again, as per the agent function, if it is clean, we have to move to the other square, and since we are in room B, if we try to move to the other square, that is, we try to move to room A, then we have to move left. So the action becomes move left. again the fourth row, it says that the percept is be dirty, and since the room is dirty, we have to perform the suck action. So these are the first four possibilities. Now remember, the percept sequence is the history of all percept. Now initially we may be in room A and room A was clean, so we tried to move to the right. The action was to move right, so we move right little bit, and then again in the next time instant we try to get the percept, and the percept will again be, we are still in room A and room A is clean. So that's one possibility. So now the percept sequence becomes A clean. It was initially A clean, again we are still in room A and the room A is still clean, in which case we should continue moving to the right because you have to move to the other room. Now the other possibility is initially we were in room A and it was clean, and then we tried to move right, then we tried to sense next input. We are still in room A, but now room A has become dirty. Someone have made the room, it was clean initially, but now in the next instance it has become dirty. So if it is dirty, we have, as per the ascent function, we should try to clean the room. So we have to perform the action suck. So like this, we have to specify what should be the action for every percept sequence. And if we continue like this, we can get an infinite table, because our percept sequence can be of any number of percepts. So this may continue growing. So it's a partial tabulation of the simple ascent function. And now, so these are just explicit specification. This is not implementation of the ascent function. If we have to implement this ascent function, whatever is specified in this table or whatever is mentioned here, if you have to implement this ascent function using a program, if you have to write a program to implement the ascent function, and once we implement the ascent function in the program, that becomes your ascent program. So now we can specify the ascent program using some pseudocode, and this is how the ascent program would look like. So we have some function to perform the action. So we have a function, this is the name of the function. So the name of the function will take as input the current location and the status. Status means whether the room is dirty or not. So the function takes as input the current location, and location is like A or B, and status is like dirty or not dirty, and then this function will return what action needs to be performed. So this is just a pseudocode. So the name of this function, it takes these two as argument and it returns what action needs to be performed, and the body of the function is like as it is mentioned here, if the current square is dirty, then you suck. So here, if the current status is dirty, then you perform the action suck. Else, so if your room is not dirty, then you have to move to the other square. So now to move to the other square, you have to find out in which room you are currently in. For example, if you are in room A, then you have to move, if you want to move to the other square, then you have to move right. However, if your current location is B and you want to move to the other room, you have to move left. So otherwise, move to the other square, this part is implemented using this code, which says if location is A, then we have to move right, else if location is B, then we have to move left. So this becomes the pseudocode of the ascent program. That's all for today's class. We have seen what we saw what a ascent is, and then we looked at what a percept is, to start with, we saw what agent is, and we saw that agent have sensors to perceive the environment, and it has actuators to act upon the environment. And we saw what a percept is, we saw what a percept sequence is, then we saw how to specify the behavior of the agent. The behavior of the agent is specified using an agent function, which actually is an external specification, and if you have to implement it internally, you may have to write a program, and that is your agent program. So agent program will take as input the sensor inputs, and then it will determine what action needs to be performed. And then we looked at a simple example of a vacuum cleaner agent, and looked at what its percept are, what its actions it can perform, and we saw the agent function for it, and then the agent program. So with that, I would like to stop for today's class. Meet in the next class. Okay, thank you, bye.